Ladies and gentlemen, good late afternoon from my behalf. It's an absolute pleasure to be here. Thank you for the organizers to giving me this opportunity to present my favorite topic, raute. So my name is Jari. You can forget the family name, it's too difficult for the Finnish people as well, so let's not get there. My role is the Chief Commercial Officer at Raute Company. I've been working now there since 3.5 years. I joined the company just before COVID broke loose. It's been a very interesting induction to wood-based products. My background is in technology, but let's give it a go. So, introducing Raute first, we are the leading technology and service supplier in selected sectors of the wood product industry. So we provide hardcore technology. We don't provide wood products, just to make it clear. We say that we are the only company in this area who can produce or deliver the engineering, building, construction, handing over the complete production process for veneer making, plywood making or LVL making. So we have the whole product portfolio supported with the technology services. That's what we do. We have been now discussing a lot about the challenges in Chile, but we have also been discussing a lot about the opportunities that the megatrends are now offering to us and to our customers in these wood-based products and how to utilize them in construction industry. We see this as a perfect time to be in this business. All the megatrends are supporting us. That's good. And then of course we should not neglect the opportunities offered by digitalization, artificial intelligence. That opens a whole new world when we speak about making the production processes more efficient. So that's another opportunity that we see very strongly. Raute today, we are a company of roughly 150-160 million euros by annual turnover, a little bit less than 800 employees around the world, and we are serving some 350 different customers around the world. That's roughly in a nutshell who we are. But we have more than 100 years of history in Raute, actually 114 years. So we were established 1908 and we started manufacturing different kind of technology products from vessels, steam boilers, all the way to furniture, among other things. But as early as 1930 we entered into this veneer machinery manufacturing and business and started that. So very soon we can say that we have 100 years of experience on how to build good quality veneer, plywood, LVL machines. We have been expanding and growing both by size and by geographical coverage. Naturally, like many other Finnish technology companies, at 50s and 60s, we were doing mostly business to the east direction. Well, since 2022, we don't do any business to the east direction, if we mean Russia or former Soviet Union anymore. That's done, at least as long as I'm alive, I would say. It takes more than a generation to fix what they have broken in 1 year. We are today a publicly listed company in Helsinki Stock Exchange. So at 1994, the owning family that built us and owned us in 3 or 4 generations decided that they will list us, and they still continue as one of the majority shareholders, but we are a publicly listed company. What you can see in a growth path is our specialization at the very early stage in machine vision. So that's one of our core competencies. We are very much including all kinds of analyzers, sensors and machine vision into our production lines to replace the human eye. And that has been one of the key success factors to our businesses. So at very early age we started taking benefit from everything that the digitalization can offer. And we have acquired that technology, we have some parts of it inbuilt in-house, and the latest acquisition was 2020 when we purchased a machine vision software company from northern Finland. So that's been a clear strategy for us and clear focus area. Like I said, we can deliver the whole factory, all machines that is needed for producing plywood. This is an example of a plywood mill layout. We start from the peeling, we peel the logs to veneer, then we dry them in this huge drying machine, and then we can start handling the dry veneer sheets. So we can patch them, we can compose the joint, the random pieces to thicker sheets. We can do scarfing where we extend the length of the peeled veneer. Then we make a layup put the glue in between the sheets, start pressing, go to the high press, and then we have these pressed ready-made plates, and we can do the finishing, whatever is needed, overlaying, sanding, cut to measure, and all that. And all this is nowadays connected to each other, so we have a digital platform covering the whole machinery. There are sensors, cameras, analyzers in all of these lines, and we can use that information to optimize the process, optimize the machinery performance, and also optimize the grading of the veneer that we peel from the wood. So we put the lower range grades into the core of the plywood and use the best sheets as a surfaces and create most economical way the very good looking, nice, high quality plywood, or LVL. The LVL process, the start end is the same as for plywood, but then it changes from the layup and pressing line onwards because the pieces are different dimensions. Like said, what we say about ourselves, and we want to be a full scope solution partner. So our core technology is the technology offering for production of veneer plywood and LVL analyzers I mentioned, and then to support all that is the life cycle services that we offer in-house. So that is really what we want to be. We are truly international company, very much born in Finland, very much Europe-centric, but we do have a sales and service office in Construcción in Chile, where Sebastian Mauricio is the regional vice president responsible of sales and customer support. We have Juha there as well, head of services in Latin America. And this is because we have had a very good fortune and luck to have decades-long customer relationships in Latin America. For example, two of our very big customers in Chile, CMPC and Arauco, were mentioned earlier today. So we are established there. We are established in North America and then in Asia Pacific area, and of course Europe is our home territory. Our headquarters and main production facility is located in Nastola, close to Lahti, the skiing city of Finland, where we have the production plant, R&D center, and headquarters. We do have competence center in Vancouver, in British Columbia, Canada. We have the machine vision and moisture analyzing technology center in Kajaani. That's very exotic, but that has a history behind why it's there. And connected to the Kajaani unit, we have this new software company now in Oulu, in northern Finland. Then we have the grading technology center in Pullman, in USA. We have a factory in China, in Changzhou area. Actually, it used to be located in Shanghai, but having a factory in Shanghai city area became far too expensive, so we just moved it 300 kilometers northwest, and now we are happy with that. And that we did under COVID area. That was very interesting project to follow. Sales and service hubs, like I said, Singapore, Indonesia, Chile, and the latest ones now, the service points that we have opened in Italy actually. There are Australia, Latvia, and all these ones. So, and gradually we are trying to expand our geographical coverage as we move along, always based on our customers' locations. So where the customers go, that's where we go with our services. Like I said, main customer groups, we are serving veneer producers, we are serving plywood producers and LVL producers. There is, by the way, a very interesting big difference between the concepts, how these companies are working in different corners of the world. In Asia, in North America, there are specialized veneer producers, and then they sell veneer to whoever needs it. In Europe, in Latin America, very typically, the veneer production and the end product, being that plywood or LVL, is produced in same location. But we are happy to serve all, with technology, with service, and then this digital layer on top of that. The data is becoming more and more important and interesting area to focus on. We serve customers from very small private companies up to multinational corporations, and we are very happy to do that. It's quite interesting to understand the differences, how these different sizes of companies operate. But the production process is still the same. So no difference in that regards. And like I said, last year we served some 350 customers. And interestingly enough, there are a lot of new companies now coming into this industry. because of they are owners of plantations. And plantation wood is coming to an age of harvester. And these people are trying to figure out what is the best way to utilize that wood source that they have now suddenly available. And if you ask my opinion, I'm not representing company, it's only personal opinion, but if you really want to take maximum out of your logs, peeling is the best way. It produces the less amount of waste. Few words about R&D. I think technology and R&D was the scope of this presentation, even if it's very short. Like I said, we have the full range of products serving the complete production process, which means that we are utilizing very many different technologies in-house. When I joined, it was really mind-blowing to see that in one machine that is handling veneer sheets, you have hydraulics, you have pneumatics, you have automation, you have sensors, you have machine vision, and then you have traditional motors and gearboxes and all that. So all these elements of machinery engineering, and that's my background, so it's very fascinating. So we need to have quite, I would say, wide technological understanding within the company. And we need to invest very heavily in R&D. And that's what we do, and that's what we are known for. So good year, bad year, every year, minimum 3% of our turnover is invested in R&D. And you can blow that money out in so many different ways, but these are the core things that we are trying to focus. So most efficient use of raw material, that is the key. And this is what is very much resonating with our customers. Everybody wants to take the most out of the wood. And that's why we are trying to improve our machinery all the time to minimize the waste and try to find ways how we can maximize really the yield from that log. Less energy, that is becoming more and more important. It used to be less labor, but now it is turned to less energy. That's the second primary driver at the moment. Then this additives, glue coating thing is becoming more and more interesting, especially now there's a lot of focus in the glue sector and how we can develop more this kind of glues that contain more biological material. And we are in those development projects at the moment. It's very, very hot area. The product quality is always on a very high focus, and this productivity. But I would say that at the moment the core is rather on the top 3 topics than the 2 last ones. And of course, nowadays these responsibility questions are becoming more and more important as we move forward. And actually, I'm very happy to inform that we have published our first ESG strategy document this year. And it's not anymore, how would I say, a consultant drive. It's reality. We have to be in that game. Of course, UN Sustainable Development Goals in the areas of human rights, labor, environment, and anti-corruption goes without saying. We comply with the principles of good corporate citizenship. Our values and code of conduct, by the way, was renewed, and we had that published this week, actually. So we are taking all these things very, very serious. And ISO certification in Nastola unit goes without saying. A few words about the economical performance. I was referring to our business with our good Eastern neighbor. Back in 2021, when we went into 2022, 42% of our order book was coming from projects designed to Russia. 42%. And we lost that overnight. So you can understand what kind of devastation that was to the company. Last year was not the best one in terms of numbers, but I just wanted to pick up a few highlights what we have done since, so that I'm not leaving any kind of dark remark into your memories. So first of all, we have had this year extremely good start. In Q1, in January, we booked a 49.6 million euros order from Uruguay in Uruguay for the Lumin plywood mill. That's one complete mill from start to finish with our machinery. There has been also very high interest in modernizations, especially in Europe and North America. So it's been good. And on top of this order, we have booked 2 other mill size orders this year already. So 1 plywood mill to Latvia and an LVL mill to France. So it has been a very, very good start. We have also stated new strategy. Our top management has changed since 2022, including CEO, CFO, CIO, CPO. Did I forget some letters? But you can understand that this has been really a year of change to our company, a big time. And we have also taken very strong actions to strengthen our balance sheet. There is actually a shares issue going on as we speak. So after Q1, even though the net sales was below previous year, you can see this EBITA impact. So 2022 Q1, Q4 minus 2.3, this year Q1 plus 2.8. So we have made a turn. And the full year figures I'm not even going to mention because it was a devastating year too, because of the write-offs of the Russian project. However, it is looking good. Order intake has been very strong, like this is only Q1. When we put now Q2 with these 2 mill-size orders on top of that, it looks better than good, I would say. And our order book already after Q1 was all-time high. So it's not the end of the world, this is the new beginning for Raute, and we are happy to continue serving our customers around the world, and especially in Chile, which is a very, very good and important market for us. I'll be staying here if there are any questions afterwards, but at this point I thank you all for your attention.
Yes, good afternoon all. My name is Tomi Toratti. I lead the Northern European Sales and Business Development team here at Stora Enso Building Solutions. Very happy to be here today. Thank you for the invitation to organize. Also very happy to see the sort of whole value chain here. We are a happy customer of Raute, and we have our hopefully happy customer also puurakentajat here as well. So very happy to see the sort of little bit of wider effect of the value chain. I will be introducing what Stora Enso does as a group, but then especially within the building solution business, what kind of, let's say, things we deliver to our customers, but then also how do we want to drive the whole industry forward, and what kind of projects we have been delivering. The sort of general purpose of the whole company, what is in our DNA, is that we believe that everything that is made from fossil materials today can be made from tree tomorrow, or renewable materials tomorrow. And that suits very nicely also in the construction industry, where we have a huge CO2 problem with our sort of current methods of building with steel and concrete. So this is why we are also very sort of strongly in the construction value chain. Just briefly about the company in general. Last year we turned over roughly 12 billion euros. We are pretty much of a sort of a European-based company. We are from the Nordic countries, I would say. Actually, the name of the company comes from 2 parts, the Stora part and the Enso part. Just sort of reflecting on history as well. The Enso part is the Finnish part of the company. It has a history of roughly 150 years in Finland. The Stora part is the Swedish part of the company, and that has a history of more than 700 years. So Stora is actually sort of one of the first, or the first, sort of shareholder company, where there were plenty of shareholders back already in 2088, if I remember correctly. So plenty of history also behind the sort of both Stora and Enso side of the company. Like I said, we are sort of pretty much sort of European-based company, Nordic company, but we are also sort of truly international player and also operating in the Latin Americas as well, and more perhaps known on that side of the world for paper and pulp sort of industries. Back in 2006, when I was practically finishing my master's degree, I was thinking of Stora Enso as a paper company which would be run over by digitalization in the next few years. So not interesting employer at all. But what I didn't realize back in 2006 that Stora Enso had already started a sort of complete transformation journey from a paper and pulp company into a truly a sort of renewable materials company. And nowadays actually 48% of our business already comes from our sort of future growth businesses. There's been a massive transformation of our business in the past 15 years. And you can imagine that there has also been quite massive transformation in the past 700 years. We were actually in the beginning also working with timber, but using it in a lot more, let's say, primitive ways in the mining industry. But yes, this sort of transformation journey that the company is in, and we have defined three sort of longer-reaching R&D and innovation areas where we see the future of the entire group heading. One of these areas, surprisingly, is the carbon-neutral building solutions. So that is why I'm here as well, and that is why we are so heavily invested in construction value chain. Other areas we have is sustainable packaging innovations, and the third one also on the lignin-based innovations, where our cooperation with battery producers is one of the sort of key areas driving the sort of future innovation as well. Very sort of interesting things happening on other sides of the group as well, but of course our sort of interest and focus is on the carbon neutral building solutions, where we see that we can really sort of have a massive systemic impact in the construction industry value chain by pushing this sort of boundaries of carbon neutral buildings. And if we compare the sort of different kind of innovations that we are focusing on also on carbon neutral buildings also is the one that creates sort of longer standing carbon storages as well. So we build for 50 years, we build for 100 years. So the carbon remains stored on those buildings also for very sort of a long time in comparison to the packaging industry works. So diving into the wood products division, which is the division I represent, we have, let's say, set ourselves certain targets that we want to achieve in the construction value chain. So first of them is, of course, to sort of raise the awareness. We feel that as a big company, as a large company, we have the obligation also to promote the sort of more renewable, more carbon smart ways of building and promote the sort of climate smart choices. We also see that there are the sort of certain trends in the world, globalization, urbanization, then also this sort of strive to solve the climate sort of crisis, I would say. What we want to do, we want to develop industrialized solutions for it. Not just taking the sort of things that are normally done on the job site and doing those in a factory. That would be one step perhaps towards productivity, but taking those elements of work that is usually done in construction site, doing those in an industrialized manner in our production. As an example, I could sort of point out, for example, our 10 million investment in Austria into an automated coating line. So things that were traditionally done manually on construction site, first they were done manually in our production, but now we have invested into an automated line which does the same thing a lot more productively as well. And when we started this journey, actually, we were mostly sort of considered also as a raw material supplier. First raw material as classic sawn for construction industry, then raw materials for ready-made elements. But then we really sort of wanted to take a step further from that and start delivering, let's say, even more and more ready building components. And then also developing from the building components into building concepts, how to utilize the components in the most efficient way. I will come back to that a little bit later stage, but yeah, we are also here to help our partners to differentiate and get a sort of competitive advantage. The two products that we produce ourselves at the moment are cross-laminated timber CLT. You were visiting the Wood City offices, the second phase. Today, for example, there the floor elements are from CLT provided by Stora Enso. Then the other material that we produce here in Finland, in Varkaus, is the LVL, laminated veneer lumber, which Raute builds the machinery for as well. So that is where the sort of common interest and link is coming from as well. From CLT, you would normally do this sort of large-scale building elements, floor elements, wall elements, whereas the LVL is more often used, I would say, in different kind of column and beam structures. So those are the sort of typical applications that these are used for. Just to give us some sort of picture about our production platform, in good and bad, I would say that currently we are the biggest sawmill in Europe, or sawmiller. So we have roughly 70 production units currently in different locations in Europe. We used to have a few sawmills behind the Russian border as well. Not anymore. Those were, let's say, we cut those parts, so part operations quite immediately after the invasion started in Ukraine. So no sort of mills on that side anymore. But when we sort of developed or built the building elements, building components, those are on our 4 CLT mills. So we started our journey in mass timber construction actually from Austria, where we built our first mills in Bad and Leonhard and Itz. That was back in 2007, 2009, if I recall correctly. And from there, actually the sort of expansion started. CLT originally was an Austrian innovation as well, so it was invented there. That's where the first markets were, and that's where we also started our journey and our first sort of round of investments. Already quite soon we started also exporting from Austria to Nordic countries, and the market started to develop in the Nordic countries. And back in 2019, we were ready to start our own sort of CLT mill in Nordics, in Gruvön in Sweden, just quite close to the border of Norway as well. And the Gruvön mill currently serving the sort of Nordic markets, I would say, very nicely with very sort of good logistical setup for the whole Nordics, including Danish and Baltic countries as well. Our latest expansion in CLT production was in Stierec in Czech Republic. That mill started last year and has been in commercial operation from January this year, now ramping up as well. With these sort of 4 CLT mills, we are also the biggest CLT producer, actually globally. I was about to say Europe, but let's think globally because CLT is from here. And then for LV, we have our production unit in Varkaus, and that has been operational. You probably know better than I because it was started before I joined the company, just before the pandemic, but I think it's from 2019 or 2018. So very sort of a new investment as well, and quite sort of well ramped up. But as mentioned earlier, we don't want to be a raw material supplier. We don't want to supply CLT or LVL to the market. We want to think of ourselves as an element supplier and take things further. So that is why actually last year we also launched a brand for our element supply, and that brand is Silva, and this is called the sort of Silva kit. So what we are supplying instead of CLT and LVL or glulam or any sort of raw material, we are supplying walls, we are supplying flow elements. They can be further processed flow elements, for example, as CLT rip elements or CLT LVL rip elements. They can be stairs, ready sort of CNC processed in our production facilities in Austria, in Sweden, and then also beam and column elements. So for that we have our own production in LVL, and then we also work with other producers to provide glue laminated timber to complement our offering so that we can provide buildings a little bit more sort of as a comprehensive package. But even that is not enough when we are, let's say, talking about new building typologies, when we are talking about new kind of markets as well, new customers, new developers starting their first mass timber project. So that's why we also saw that it is important to take one step further, and that step is building concepts. So with building concepts, we are trying to sort of make the best working combination of different kind of building components that we have. This is just sort of nice rendering of a residential building, but combining CLT rib elements, CLT balconies, CLT walls as well. But the idea is here that we provide the sort of best potential, best performing combination of our silver kit in order to deliver most value from a building. So that is the sort of thinking in this sort of building concepts. And so far we have developed building concepts for office buildings, for residential and multi-story buildings, for school buildings and industrial buildings, and also from a little bit different kind of thinking as well. For example, on the residential multi-story buildings, the sort of quite common options that you might have would be volumetric elements or 2D elements that you would use to build the residential building. But what we talk about nowadays even more and more is the lifetime adaptability of the building, and actually having load-bearing walls in the building, for example, prevents quite a lot of the lifetime adaptability. That's why we have, for example, the last sort of launch has been on residential multi-story with post and beam system or column and beam system, which allows a lot wider lifetime adaptability of the building. But those are all freely available on our website as well, so something to look for. What we promise with these, they should be scalable, they should be optimized for cost effectiveness, low carbon, also for DFM designed for manufacturing and assembly, so thinking about the production in the mill, but at the same time thinking about the assembly work on the construction side. And we are all the time developing more and more different kind of concepts or different building types and typologies as well. So, and we are also not leaving it there. We want to work with our customers also something localizing the concepts. So really sort of proof testing, how does this work in practice? And for example, this morning there was discussion with an Irish developer who wants to build a big warehouse in Denmark, and it's just sort of good sort of a showcase that, okay, let's test it, how does our concept really sort of fit in their needs, and how can we adapt it to the Danish building regulations. Just to show some sort of very nice pictures of different projects that we have delivered. This is actually outdated information. This is currently the world's second tallest timber building. We have delivered CLT within this building, but tallest one is in Milwaukee. I think they went 2 meters above this. So yes, of course. Yes, actually this was about to be run over by some other building, so they made this sort of lular triangle on top to make it a little bit taller, but that wasn't enough, so they should have went a few meters beyond this. But constant competition here. Wood City, yes, you saw it today, but there's sort of first part, which was the residential part, which was done with LVL. Then there were Supercell offices. This was also done with LVL from our Varkaus production. So also roughly at the time when Varkaus production started, a little bit different kind of technologies combining the LVL ripple sets, LVL post and beam system here as well. And actually, not very sort of a common way of building with, let's say, fast timber, that there's not too many buildings that would be purely made of LVL, but LVL ripped elements, for example, are sort of common usage. And now the part that you saw today was the sort of latest two offices, which are now being built actually from glulam and CLT, so trying to again different kind of technology, and glulam and CLT is also quite sort of nicely going hand in hand also with the office building concept, so they could have some inspiration from there. And as we're talking about Chile, we haven't delivered massive buildings in Chile, but we have delivered to other let's say, sides of the world. And that's why I also want to just highlight a few cases from Australia. And one might ask how sustainable and how economical it is to transport mass timber from Austria to Australia. Although there are only a few little differences, they are on the other side of the world. It's the beauty of mass timber anyway, that we can fill up the containers fully. We can utilize the whole sort of transportation capacity of a container, for example. And in this case, especially it helps that there's actually a massive amount of containers coming from that part of the world to this direction, and a lot of empty containers going the other way. So actually filling those empty containers with CLT is actually very economical and also sustainable. So actually in these cases, this was sort of from sustainability point of view, very sort of successful projects cutting the CO2 footprint by well, not going to sort of exact figures, but at least 20-30%. In these cases, a typical sort of glulam post and beam system that you see here, and then CLT walls and floors. The other one that we have delivered to Australia, also in Sydney, the international house, also with the same developer, Lend-Lease. But we have two sort of good showcases with Lend-Lease in Australia. Very sort of nice looking glulam and CLT buildings, both glulam and CLT in this case came from Austria. And then to finish just with our own head office project, which is currently being constructed in Catalin. We are also putting our money where the mouth is, or actually the sort of owner of the building is Varma, the sort of pension fund is the investor, but we are the anchor tenant in the building. Nowadays, listed companies don't usually tend to own their own head offices, so there's a pension fund owning the building, and there will be a hotel operator in the other end. The bottom floor will remain open for all citizens as well. So hopefully within a year you will come back to Helsinki. You will have a nice sort of access to the building. You can freely have a sort of a dinner at the restaurants on the bottom floor, or be a nice summer day on the rooftop terrace. So that will be a completely open building. And yeah, few renderings of the architecture is not there yet, but Mikko hopefully will build these sort of nice curved structures for us as well, and we will have those ready within a year. And this is the situation from yesterday. So this was the webcam picture from yesterday. The project is also has a sort of a live webcam following, so you can also sort of check the situation on the site. But made of five different blocks. This is sort of used to run offices. This part will be the hotels. So probably we'll move into the offices before the hotels. And this is the sort of entrance and atrium part of the building, which is formed as a circle in the middle. But this was all from me. Thank you for
So good afternoon from my side as well. My name is Maija, and I come from a company called Wood, one of the owners of the company, but also in charge of sales and marketing and products. And I even have a piece of a product with me, so we can. I will not talk so much about the company, but the methodology and the product itself. Wood is a 22 years old company, and we are producing thermally modified timber with a method that was actually invented in Finland about 25 years ago. So all of the thermal modification basically that's happening in the industrial scale in different parts of the world has its roots in Finland. It was developed by VTT, and now the patents for the production are owned by an international thermal association, and we are using that method. Our roots are in Iisalmi, so when you're going to Joensuu tomorrow, so quite close there, a little bit further up north. And I think that this is pretty much the picture and the view, or this one, you will see from the plane tomorrow morning. So we are a very forested country, like you guys were saying, 24% of Chile is covered by forests of the land area. In Finland it's about 75%. And our whole story starts with the wood, with the forest. Wood, I'm quite often asked where the name comes from. It's not Termo wood or Termo something, or kilning or barbecued wood. Wood. The story comes with the moon, and people in old times in Finland used to believe that if you are harvesting timber during full moon times, it will get superpowers. And our timber is not harvested during full moon, but our timber is super timber, and you will soon see why. So everything for us begins in the forest. We are buying the raw material currently from over 35 Finnish sawmills. We can't buy our raw material from one sawmill only, because there will never be enough, this very narrow spec that we are purchasing. We are only using a certain part of the tree trunk, a certain part of the wood, and only the center cut section. So actually the thermal modification globally is not a heavily growing production method, because it is so much dependent on the raw material quality. We were practicing for 10 years, failing heavily, and the reputation of thermowood is not very good in Finland. So our export share is currently 98%. We are still struggling in Finland, and we are only starting to get first public references over here, whereas we are operating in 65 countries around the world, mostly with architects. I'm not an architect, I wish I would be, but I'm not, I'm an engineer, sorry. Sorry for that. So what do? We buy a very tight spec of the raw material of sawn timber. We stick stack it, so we put sticks in between of the layers like normal timber drying. But we don't just dry the timber, we barbecue it. When the timber goes into the kiln, it's very light in color, like normal, nice, beautiful sawn timber. When it comes out, it's brown. This is the color out of which the color that comes from the kiln. And we are only using heat and steam in our production. First, we slowly dry the timber up to the moisture content of absolute 0. So we push all of the 20% of moisture out. Then we take the temperature quite high, up to 212 degrees, which is the optimal temperature for Nordic pine and spruce to be barbecued in. And then after that, we keep it there in about 2-3 hours, where the actual thermal modification happens. The cell structure of the timber changes, so the hemicellulosic chains inside the wood, they will break, and the cell structure crystallizes, so that the wood does not absorb moisture anymore back in the same way as it normally. Wood is like a sponge normally, so we prevent that. This method is a method that would happen in the forest in 400 years. So after the wood comes from the kiln, it's basically dead. It sounds bad, but the cell structure is basically dead. You were asking about the moisture content. The final moisture content, after putting a little bit of moisture back into the wood, is about 4 to 7%. From 4 to 7, you can take a piece in your hands and try. It's super, super light in weight. And it can get up to 12% only. So when you put this into a water, it can go up to 12%. You can use Luna wood, you can use thermally modified timber in a shower floor. I've seen 15 years old shower floors, and they are in perfect condition, because it does absorb a little bit of moisture, but it also releases the moisture quickly and dries out again. And that prevents the movement of the timber when used in a very humid areas. So just barbecuing, nothing specific, taking the temperature up, drying heavily, modifying with heat, and taking the temperature down. Thermowood is the most sustainable wood material that there is in the world, that you can use in any kind of climate, in any kind of decorative end use, without any chemicals. That you need to remember that. Sustainability is super important for us. As a company, our turnover is 75 million euros last year, and sustainability initiative is our main cornerstone in our strategy. And we look at the sustainability from the whole value chain point of view. Of course, we are only working with Finnish timber. We're actually the only company in the world. We're the largest manufacturer of thermally modified timber in the world, and we're the only company in the world that produces thermowood out of Finnish raw material only. So everything that we use is Finnish pine and spruce. But it's not only the forestry operations, which are in Finland, of course, super sustainable, but we look at all the different phases of the life cycle. And we have already started to discuss about carbon footprint over here. And we are also, Tomi, often asked the question that why are you transporting timber to 65 countries? Is it sustainable? But if we think about the carbon storage of a wood product compared to the production emissions of Luna wood, actually our wood is storing 5 times more carbon than the actual emissions are. So even if we transport these to Chile, or even if we transport these to Australia, still the carbon would be, this would be a carbon negative product, which is a positive thing, although it sounds a bit off. And we are using the same container shipments as you guys are, and the lightweight in the product helps in terms of the carbon footprint. And the other thing is that we are expecting with this kind of dry timber a very, very long life cycle of the product in its final end use. I'm always saying that this can last 50 years in Dubai. Our CEO, who is flying even a bit higher than I am, is always saying that it can be 200 years in Dubai. What are you complaining? So since the cell structure has already been sort of killed, and the wood doesn't absorb moisture, it doesn't get affected by the sun, for example. Lunawood and Terrawood you can use on any kind of decorative surface. We are actually currently operating in 8 countries in southern part of America. We are also operating in northern part of America, in the US and in Canada. You can use this in any kind of decorative surface, but the only thing that you should avoid is a structural end use, because the bending strength is getting lower with the extreme drying. So for outside, for inside, for landscaping, for industrial end uses like furniture, outdoor furniture, for window frames, there are technical and visual benefits for each different end use. And I'm so happy that Tomi, you showed some reference pictures, because I have those too. I was just about 4 weeks ago in South America. I had the privilege of visiting Brazil, Argentina and Uruguay, which have been our main markets there. And now we are expanding to Chile, Panama, Colombia and Mexico. And this is a beautiful villa project. Actually, there were 11 golf villas designed by Mariana Crego. She was actually our visitor, or our guest last summer here in Finland, and she fell completely in love with me. She's been here 5 times since last summer. She went crazy. And I went to meet her and look at the villas. All of the wooden surfaces, inside and outside, there are deckings, there are batten systems outside, then there is this triple product that you have somewhere on the table, everywhere on the lower ceilings and eave parts. And this one is a sustainability project. So they wanted to have the HQE certification based on low energy consumption and carbon footprint. And that's why they were looking for the most sustainable option for the different wooden surfaces. And all of those villas have this same beautiful decoration. This project is probably our most well-known project. It's from Portugal, and it won the Building of the Year award in Arc Daily. We are working a lot with the architects. Also, this gentleman, the architect Romo of this Casa A building, was here as our guest last summer. These 2 gentlemen, they designed a private villa with a very strict privacy concept. It's in a quite deep pit with a concrete block, but then they wanted to break the image of the concrete blocks by something very sustainable, natural, and naturally weathering. So all of this diagonal facade is Lunawood. And there is one curiosity. We are always recommending stainless steel fastening to avoid the leaching of the metal in timber. But these architects, they wanted to use the normal fastening, so you can actually see some stripes on the facade, which is creating this kind of cross pattern. The wood is installed diagonally, and then the screw lines go diagonally to the other direction. And now they are saying it's absolutely fine, and that was their own choice. But it's a beautiful example of how the thermowood changes its color based on the UV, and it's a completely maintenance-free product. So if you accept the natural weathering of the product by UV and by rain and by climate effect, then you get chemical-free product throughout its whole life cycle. You were talking about South Korea as one main export market for Chile and for the wood products of Chile. This project is from Jeju Island in South Korea, where the architect wanted to have a product that can continuously start from the roof, the decorative roof, there's a proper roof underneath, and that can continue with the same visual line to the facade. And the beauty, and the first thing when I started at Lunawood 5 years ago, I stopped the production of corner protection trims. Because the beauty of thermowood is that you can actually cut the wood in 45-degree angle and install the end ends of the timber together, because these lines without the corner protection, they will not start to open up and move. So you can really enable a very prestigious design with wood without movement. And I'm always saying to the architects, it's completely illegal to cover the corners when you are using Lunar. But it's a beautiful showcase of how the same coherent design can continue from the decorative roof into the facade. Then just one more picture of the color change. This is a project in Czech Republic. The facade and the decking, they were installed 3 years ago at the same time. The decking is completely changed its color into light gray, whereas the facade is still very much brown. So this is something we're always explaining also to the architects, that if you are choosing this natural weathering, you have to understand the different angles of the sun and of the climate effect. But even with the quite severe sun, Czech is not that severe, but if this was in Dubai, the sun does not affect the timber because it is already dry. So the only thing it does is that it changes the color of the timber. Another one from Czech Republic, what you can do with the timber which is dimensionally stable, you can create 3D effects. In these parts there are lamps inside, so you can imagine how beautifully it looks in an evening time when the light comes from towards down and towards up at the same time. But you need to have timber which is stable in order to design something so prestigious. From Finland, if you are ever visiting Turku, and when you are coming back to visit the Stora Enso head office, you should visit Turku as well. This is also a public space. This is the Chemistry and Physics University in Turku. And here, in this curvy part, I always remember when I visit architects and they put the blueprints on the table and they said that, can you give us a solution of timber with horizontal installation and curvy? I was like, okay, we have to figure out a solution. And in this curvy part, there are over 3,000 individual pieces of timber carved, because you cannot bend a thermally modified timber because it's so dry and brittle. So they are carved from wider sections and they are installed into an aluminium frame. And the architect Pia, she gave us a rule that where the one timber ends and the next starts, there can be 2 millimeter variation in the alteration of the heights, and that needs to last for decades to come. So then thermowood was the only solution they could use. And it's a very prestigious design, but look what happens when you go inside. It continues, of course. 8-story high atrium space with a very demanding acoustic needs, of course, because of the students and the laboratories which are behind of the timber screening systems. And this is also what you can do with thermowood, is that you can combine the exact same product outside and inside without any chemicals, and then you can continue the design flow throughout the spaces. And I couldn't stop showing this example, although they are only renderings, but I think this will be our #1 flagship project when it will be ready. Maybe not the most sustainable sport, but at least they are believing in sustainable building materials. So this is the Formula 1 Silverstone racetrack in the UK, where they are building 70 villas, from which you can see directly into the racing track. And it's substantial that all of those villas will be cladded with our timber. And this timber will be pre-grade, meaning that there is no actual protection of the painting for the wood, but it's only changing, we're doing it in a factory, it's changing the color by pre-graying the timber. So when the timber color naturally changes, there will not be such a big variation of different walls of the buildings depending on the orientation. And like Tomi, you also described how Stora Enso is working, we are not only supplying raw material. First of all, we are always supplying ready-made profiles for the architects and for construction companies, but we are also believing in solution thinking. So that's why we have BIM models for designing in Revit and in ArchiCAD. We've got IFC models, rendering images, visualization tool, out of which this picture is, for example, from. And we do a lot of trainings. So like I was mentioning to you that we can help with teaching for the students we're working with Pekka Heikkinen and Aalto University about timber in general and sustainability and Finnish forest management. So we are very heavily involved in different kind of training programs for universities and architectural students. That's all, thank you. And you can check more from the lookbook that I brought. I can put it around a little bit, and then from Instagram. That's the best place to see some more inspiration.
Good afternoon. Thank you for the invitation. And actually, this presentation is probably very different than the others because, of course, the topic is protection of humidity control in wooden structures, but I will show an approach which includes computational modeling, which in general can support design and also monitoring and maintenance. So maybe I can also say something more about me because my background is civil engineering, computational mechanics, and I work currently at WTC, and I've been there for 16 years now, working especially on computational modeling of wood, timber structures, and also biocomposites. Well, so just one page about WTC in brief. Actually, this is a technical research center in Finland, and it's a public sector research center. As you see here, it's supported by Ministry of Economic Affairs and Employment, and we have most of EU funding for projects and, of course, research development, and we are considered a strategic partner for many companies, institutes, research funders, ministries, administrations, and so on. As you see on the right, we are distributed in several cities, 6 cities in Finland. Most of us are in Espoo, and other colleagues in Tampere, Jyväskylä, Kajaani, Oulu. You can see here there are different technological areas. So in Helsinki or Espoo, as we close to Helsinki, so we focus on these energy, smart cities, microelectronics, and also new bioprocesses. But there are many other technologies in the other cities, and we have, of course, collaboration all the time with many teams, many research areas, and of course other companies and institutes. So now something about our models. Here there is an overview about this tool set, which is called Propertium for wood. And actually it is a subset of more general Propertium tool set for modeling of materials and structures at WTC. And actually, as you see here, the concept is often called PPSP because we have process, properties, structure, and performance modeling. For example, for the process, we can model hydrothermal, hydrothermomechanical processes in wood, so drying, densification at high temperature, actually also something about thermal modification and so on. In this case, we have, for example, moisture in wood, temperature, pressures, and then strain stresses during these processes. So this can be modeled numerically. Then the properties, we can estimate properties of new products and, of course, general products which are already in the market. So material properties, not only mechanical, but also hydrothermal. And then finally performance, so we can actually follow the service life of some wooden components and see what happens under different climates, different wooden, when there are different wooden species, different wooden components, and there are of course different mechanical laws and so on. So which are the benefits you can see here on the right? Because of course, when you have also numerical tool which support your design, your monitoring, your maintenance, so you can of course reduce the need of experiment, the number of experiments, and you can check also effect of process parameters in some process like a high temperature process. You can optimize the process, and then of course you can predict material properties. You can use less sensors because of course with a model you can evaluate maybe your moisture, temperature in a wooden component in all location of the component, and then you can evaluate also the damages due to moisture, effect of coating, surface treatments, and then you can predict service life, and you can assist the activities of maintenance, because when you notice maybe that there is too high level of moisture, you can maybe repair it, or you can carry out some maintenance activity which was not planned previously. Then of course we can also develop user-friendly tools, and these computational tools can be also connected to LCA, life cycle analysis. So here just something about our models. We have developed these models in the last 15 years. Actually, as Tomi remembers, we started to develop this in several projects, national and also European. European projects like Wood Wisdom Net, Forest Value, and currently also Horizon Europe. Then there were also many European programs like these constructions, so many networks which allow it to develop research issues and numerical modeling, so that we have these agrothermomechanical models able to calculate, to evaluate moisture contents, ingredients, temperatures, so mechanical quantities, displacements, stress strains, and consequently the crack risk and decay risk in our wooden components. So as you see here on the right, you can model what happens in your component. You can see the strain and stresses, their distributions, and so on. Here there is also a concept which is very much related to what you have presented, because you have different kind of wooden products. Of course, the idea is that you start from a specific location. So this is an example for Finland. So you have Finland there. So the location can be a city in Finland. You have outdoor climates. Then you have your typology of building there. And then you have indoor climate and of course the weather outside. And the typology of the components. So you can have glulam, CLT, thermally filtered wood, cladding, whatever. And of course, material properties related to the specific species of wood, so wood, hardwood, modified wood, and so on. So this is input database that, for example, in this project, Digimos, which was funded by the Ministry of Environment, we have collected all this input data in a database. Then this database serves to calculate maybe a component under a specific weather and specific mechanical loads and so on. And we get results, and then we collect all these results in a kind of output database, which can tell you what happens at the level of crack risk and also decay risk, biological deterioration. Of course, all these results can be then connected to life cycle assessment tools. So there is possibility to couple this kind of numerical models with more known models like LCA and so on. Actually, we have the last project which is ongoing now is this 5G timber, in which we connect models like numerical models also with technologies like 5G technologies and Internet of Things to monitor different parts of the structures. also supported by these models. And here, to understand better what is this tool, there is just the example of Finland, so we have many cities, and of course the weather is a bit different in each of these cities. You have relative humidity, temperature, rain, which can be a bit different between north and south and so on. Of course, you have a website from which you get all this weather data, and then you can use this to analyze what happens under moisture effects in your component. That can be, for example, glue lamp, CLT, whatever. And this component can be, as it is, untreated, but then it can be protected by some coatings. And here there is a scheme about coatings considering this water vapor resistance, so you can have a weak coating or a standard one in the middle of this scheme, or then much resistant coating, which can of course protect your wooden component from moisture. So moisture contents, moisture gradients will be lower, of course, when you have a wood coating. And of course, in the case of thermally treated wood, you don't have any chemicals, you are maybe safe also outdoor with this protection, but these kind of models can also consider the thermally treated wood. Of course, you should have all this input data with properties, hydrothermal properties, just specific for this kind of products. So that there are actually, for example, moisture content in this cross sections of glue lamp. This is just an example because we have collected all data related to all these cities. For example, you can find this in the website of the Ministry of Environment if you get this presentation. So there is the link, and as you see, the main problem when you have moisture effects in wood is moisture gradients, because on the surface you have very high level of moisture. Then when you go to the center of your cross section, the moisture will be reduced, and this will generate, in some cases, also stresses, because of course the wood shrinks and swells, but then when you have these moisture gradients, you have somehow your shrinkage and swelling which is constrained, so that you will have finally also stresses, and stresses will cause cracks in wood. This is the reason why we do this kind of calculation to see the crack risk, to check the crack risk in this kind of components. Then of course we will have also the same approach for other components like CLT, even if maybe in the glue lamp you can have more development of cracks in a longitudinal direction due to the transverse stresses. So here this is nice picture because we have actually calculated, for example, levels of moisture gradients and levels of moisture content over 25% in different cities, and then draw a kind of map for Finland. So you can see from this map where your moisture content is too high, and there could be, for example, decay risk. So this is for the case of glue lamp. It's maybe in this case only 6 millimeter and coated case. So there is a standard coating, if you remember, there is this water vapor resistance. So in this case, when you of course protect your wooden component, you will have lower levels of moisture gradients and also lower levels of moisture content which exceeds this 25%. Because of course when you have many times during the years this high level of moisture, there is accumulation of also biological deterioration into the wood, so you can have decay problems, rods, and so on, mass loss. Same for CLT. So I mean, these are somehow digital tools that help to understand in which part of Finland or other countries you have more risks for crack and more risks for decay. This was also an example for large components like beams of timber bridges. This is our Virta bridge in Finland, close to Heinola and Mikkeli cities, and it is possible to calculate distribution of moisture and stresses in all directions of wood, so that you can see where you have levels of stresses which are in this table, which are maybe which exceed maybe the strength of your material, or which exceed your cold strength, but it's better to consider just the strength of your material, because in this case there is a real risk of crack. So it is possible also to estimate what could happen in long term, so maybe in 10 years, which is the level of moisture content, which is the level of moisture induced stresses. And this helps in general to understand better how you could eventually protect your beams, because you can use maybe a different coating, you can repaint in a certain season of the year and so on. So as you see here, of course, if you use just sensors, you will have only information in specific location of your wooden components, but with these models you are informed about what happens in each location of the component. So this is of course also an approach which helps to understand what could happen from the point of view of biological deterioration. So for example, when you have grown of brown white rock wood, okay, this is the approach we use. So we consider moisture, temperature, and a function of moisture and temperature, which is called dose. This is developed in Germany by our colleague from Göttingen University. And then there is the loss of mass. When you have biological deterioration, you can lose the mass. And it is also related to this dose. And so it's somehow useful to understand what happens, for example, in deckings. Even if they are thermally treated, maybe when there is a lot of rain and effect of moisture, you can have some biological deterioration. And this model helps to understand what is the moisture content distribution in, this is just a slice of your decking board, which is the dose. The dose starts to tell you which is the decking ratio of your component, which is the loss of mass during the years. So you can have a prediction of possible biological deterioration of your component. And in the world, it will help to understand how you can improve also your components. Yeah, so about this, we have already some tools available in the internet. We have implemented this in our VTP modeling factory, which is a kind of platform where you can implement user-friendly tools. And in this case, it is possible to calculate, for example, moisture content during time and moisture gradients, but by using this very simple tool, just putting there the dimension of your wooden component. And then we have also the structural integrity tool, which was developed in the Creek Design project, which was a forest value project finished last year. And also in this case, by using this dose, which is a function of temperature, moisture content, we're using the mass loss, which is another function of dose, you are able to calculate the bending strength that finally will be in your component after the deterioration due to rods that could be brown or white rods. So this is a tool that you can find also in this modeling factory website. This is ready. The previous one is in continuous development for different components. Actually also here it's just for some of these, let's say, decking cases, and also the decay type. You you can choose this different route, decay route. Well, actually here I just used this slide to ask future collaboration with Chile, because of course, as you see, we have a lot of tools, but they are mainly for Norway spruce and for pines or Nordic trees, and of course the wood species is very important. Wooden components are very similar because you use also CLT and so on, but maybe you use different wooden species. In this case, of course, the models should be a little bit modified. I mean, mathematical model is the same, but material properties will be different. So the models should be first validated against maybe some tests and so on. And of course, location will have also different climates, but basically, the mathematical model are the same. So that similar tools could be developed also for other countries like Chile and others. Uruguay, we had also actually some collaboration, just meetings like this with Uruguay previously, and the results can be given in terms of catalyst and decay. So this is possible application also for possible future collaboration, and considering that we have already validated a lot of models with these Nordic trees and so on. So I mean, they are already published as results and as validations. Well, I think I have already finished, and thank you very much.